Bismillah ar-Rahman ar-Rahim. In this session, we will discuss mass and weight topic under O-level physics and IGCSE level physics. And for this purpose, I have chosen a book of physics written by Tom Duncan and Heather Kennett. And it's first published by Hodder's Education, and is very important from the examination point of view. Here we have test yourself on page 23 some examples. So here an object of mass 1 kg has weight of 10 Newton at a certain place. What is the weight of 100 grams, 5 kilogram and 50 grams? So we know that mass is 1 kg and the weight is 10 Newton. This is the given information. So from this we will use this information to obtain the value of g. So weight is equal to mass into gravity, acceleration due to gravity. So this gravity is given as W upon mass, so or it's also called gravitational field. So weight is 10 newtons and kilogram is 1 kg, so it gives 10 Newton per kilogram gravitational field. So by using 100 grams mass, we have to convert it into a kilogram. So we divide it by 1000 kilograms per kg, so it becomes kilograms. So this kilogram is used in place of this mass and then multiplied by with this gravitational field, and it gives 1 Newton. Similarly 5 kg, so 5 kg multiplied by this gravitational field gives 50 newtons. 50 grams, first convert it into a kilograms, and this gives 0.05 kg, and we multiply it with the gravitational field and it gives 0.5 newtons. Similarly for this one, the force of gravity on the moon is said to be 1/6 of the earth. So the gravity is higher on the earth, 6 times higher on the earth than the moon. So the gravity on moon is 1/6 of the earth gravity on the earth. So the force of gravity is equal to on moon is equal to 1/6 of the force of gravity on earth. This information is given, and we know that the force of gravity on earth is given as acceleration due to gravity or gravitational field strength, or acceleration due to gravity is given as 9.8 meters per second square. The force of gravity on moon is equal to 1/6 of this value, so it becomes 1.63 meters per second square. And we have given a mass of 12 kg, and we have to find the weight on the earth and the moon. So for the earth, we have this 12 kg into 9.8, so it gives 117.6 newtons. And similarly for the weight on the moon, so this gravitational field strength is 1/6 times less, so this is 1/6, 9.8, so it becomes 19.6 Newton. Similarly on this, an astronaut has a mass of 80 kg. Calculate the weight of the astronaut on the moon when the gravitational field strength is 1.6 Newton per kg. So we have to multiply with this one to give the results. So we will multiply this 80 kg and weight on the moon, gravitational field strength is given as 1.6 Newton per kg. So we'll multiply this with gravitational field strength, and this kg cancel, and it gives 128 newtons. So similarly on the journey back to the earth, the astronaut reaches a point X where the gravitational field strength due to earth and the moon are equal in magnitude but in opposite direction. State the resultant value of the gravitational field strength at X. So we have to find the gravitational field strength at X. So at gravitational field strength at X will be the half of both. So we will add both gravitational field and divide by 2 to gives 2. So we will obtain 5.7 newtons per kilogram. So multiply this with the 80 kg, and then we have this kind of weight of the astronaut at that level. So exam style questions. Explain what is mean by the mass of an object. Mass is a measure of the quantity of matter in an object at relative to an observer, at rest relative to an observer. So mass is always measured in the amount of matter at rest position by any observer. So weight is a gravitational force on an object that has mass. So weight is always use gravitational force on an object, and it should have some mass. So mass multiplied by the gravitational field strength to give some weight. So this is how weight may be compared. So how weights may be compared. The weight of an object can be measured by hanging it on a spring balance and marked in the newtons. So state which of the following definition for weight is correct. So m into g. So this C is correct. So which of the following property is the same for an object on earth and on the moon? Weight, mass, acceleration of free falling, and gravitational field. And no, only mass. Mass will be same everywhere. So state the SI units of weight is Newton. Acceleration of free fall is meters per second square, or newtons per kilogram. Gravitational field strength is Newton per kilogram. Define gravitational field strength. It is defined as the force acting per unit mass. Force per unit mass. Gravitational field strength is a vector. It has both magnitude and direction. Gravitational field strength is weight upon mass. So this is Newton, this is kilogram. This is measured in Newton, and this mass is measured in kilogram. On the earth, the acceleration of the free fall is 9.8 meters per second. On Mars, the acceleration of free fall is about 3.7 meters per second. The weight of the Mars rover opportunity on the earth was 1850 Newton. Calculate the mass of the rover. On the earth, the acceleration due to gravity is given as 9.8 meters per second. On Mars, the acceleration due to gravity is 3.7 meters per second square as given. So weight on earth is 1850 Newton. So weight of mass of the rover. So we can obtain the mass by dividing the acceleration due to gravity. So it is 188.78, and calculate the weight of the rover. So we will multiply this with 3.7 meters per second to obtain the mass on weight of mass rover on Mars. So on Mars, so this is the gravity on Mars. So we'll multiply with the mass. So we'll obtain 698.47 Newton. Explain what is meant by a gravitational field. Gravitational field strength force per unit mass. It is measured in this. The force of gravity acts through space and cause an object not in contact with the earth. So if some object is falling toward the earth, it is not contacted with the earth, but the field that is pulling that toward the earth. We try to explain its existence by saying that earth is surrounded by a gravitational field which exerts a force on any object in the field. So if it's available within the gravitational field of the earth, so it will be pulled toward the earth. So state earth surface. State the effect of the gravitational field on a mass. So the gravitational field is equivalent to the acceleration of free fall. So define gravitational field strength. It is already defined earlier. So the gravitational field strength on Venus is 8.8 newtons per kg. The mass of rock is 200 kg. Calculate the weight of the rock on Venus. So we'll multiply this with this kilogram and we will get the mass. So this is 1760 newtons. So that's all from, and in the next session we will discuss